All right, so let's talk a little bit more about derivatives, specifically derivatives at a point. Now, the words that you've seen magically show up on your screen are all the same thing. So I just want you to be aware of different ways that we can ask for this, right? One is the derivative. Now, we've been talking about the derivative being the slope of the tangent or the slope at a particular point. Now, this can also be the same as the instantaneous rate of change. You learned back in Algebra 1 that the slope was the rate of change of a line. Well, what is the rate of change at a specific point? Well, it is the instantaneous rate of change, which is the derivative. Now, this is very, very useful in many subjects like economics, physics, chemistry, where you have things that are always changing, and you can now find a rate of change or a delta something at a specific point rather than just over a range of time, which is very useful when you're trying to deal with reactions like thermal reactions and nuclear reactions that really you need to know now, not over a span of time. Now, what I'd like to look at today is how we find the derivative at a point. So let's take an equation. Let's say that we've got f of x equals 2x squared plus 3. And what I would like to know is I would like to know the derivative at 2. Now, there's a couple of ways to do this, all right? And I'm going to show you 3 of them, I hope, in the next couple of minutes, all right? The first way to do this is to actually take the derivative. And so we get the derivative function first and then deal with it, all right? So let's try that first. We'll go ahead and take the derivative. Now, I'm not going to go through the whole process because that's in a previous video, but I am just going to magically make it appear. Magically appear! So there we go. I found the derivative of this function, which is strangely a lot like the one we did in the previous video when it was 2x squared minus 3, right? Because these are just transformations of each other, right? 2x plus 3 and 2x minus 3. This was 2x minus 3. 2x plus 3 is the exact same graph, except it's shifted up. The slope at any given point is going to be the same, right? At this x value, it's the same. At this x value, it's the same. At that x value, it's the same, because all it is, it's been shifted up or down. And so when we're talking about the slope, it doesn't matter up or down. All we're finding is the slope. So yes, the derivative is the same as it was for the 2x squared minus 3, for those that noticed that. For those that didn't, now you know. So now that I know f prime of x, then I can now go f prime of 2, which is equal to 4 times 2, which is 8. So f prime of 2 is 8. Done. Not so bad, right? Okay, well, let's talk about another way of doing it. Let's do method number 2. Now, for method number 2, we're going to take 2 points. One point is when x equals 2, and f of x, then the y value is f of 2. Right? So that's 1 point. Now I can put 2 into my function. If I put 2 into my function, I've got 2 times 2 squared plus 3, which is then 2 times 4 plus 3, which is 11. Okay, so 2 comma 11 is 1 point on my graph. Now I'm going to have a second point on my graph, which is x comma f of x, right? So any other point, any other x value, and the y value associated with it. Now what I'm going to do, remember when we talked about derivatives, we took this point and we brought it really, really close to that one. So let's write the slope between these 2 points. The slope between those 2 points is going to be 0.2 minus y1, y2 minus y1, over x2 minus x1. Now, that's the slope, but I want the slope when this x value gets really, really, really close to 2. So how do I do that? Well, I just take the limit as x approaches 2. And so that's what we're going to do. We're going to find the limit as x approaches 2. Now, in order to do that, we're going to have to now work this out, because if I put 2 in for x, that makes the bottom 0. So this is where our stuff with limits comes into play. So one of the things I need to do is I need to rewrite it, because f of x is 2x squared plus 3. So I'm going to go 2x squared plus 3 minus 11 over x minus 2. All right, so I'm going to simplify that. I'm going to have the limit as x approaches 2 of 2x squared minus 8 over x minus 2. And we hope and pray that this is going to factor, which it does. I don't need the line. And I go as x approaches 2, and so I factor out a 2, and so that'll leave me x squared minus 4, which then factors to 2 times x plus 2 times x minus 2 all over x minus 2. We cancel out the x minus 2's, leaving me with the limit as x approaches 2. So again, that x approaching 2 is talking about this point right here, getting really, really close to that one so that I can find the slope at that point. That was the idea behind the derivative. So 2 times x plus 2. At this point, since the denominator thing is gone, now I just put 2 in for x. So I go 2 times 2 plus 2, which is 2 times 4, which is 8. Looky, looky here, it's the same. There you go. So there's method number 2.